Welcome to the Rich Report, a podcast with news and information on high performance computing. Today, my guest is from Bright Computing. We have Ian Lumb. He is the Bright evangelist at the company. Ian, welcome to the show today.
Thanks very much, Rich. It's an absolute pleasure to join you.
Well, thanks for coming on, Ian. We recently had this paper on insideHPC. It was published with Bright Computing, but it was written by Douglas Edline. And I wanted to, kind of deep dive a little bit on this and talk about how to manage a cluster before they even go out and issue the purchase order. And I thought, why don't you and I talk about, some of these requirements? And you came back with a slide presentation.
Yes, well, fortunately, I did have Douglas's excellent white paper to help to guide me, but it's a very timely topic, Rich. And as you say, it's the kind of thing that really can be considered at a number of different stages, even prior to purchase. Absolutely.
Yeah. I was really excited when we were able to get Douglas to write this because I learned a lot. I always thought of a cluster as something you just planned out from one point in time, and it was like an engine, right? It's just the car, the motor in your car, and yeah, you might replace the spark plugs, but it sounds to me like this is a much different animal than what I thought at first.
Well, and I think your preconception, if you like, is probably not that dissimilar from how others might view this. And I think part of that is because, frankly, the landscape has changed. Just like the automobile landscape has changed since, I'm not sure how far we should go back, but let's face it, if you use that analogy, the landscape has definitely changed. And so as I was saying, I really do think that Douglas's white paper is actually extremely topical at the current time.
Well, great. Well, why don't we go into your slides, and then we'll do a little Q&A at the end.
That would be great. So the first slide's just a title slide, and as you can see, I've boldly taken the title from Douglas's white paper on 5 essential strategies for successful HPC clusters. And that successful word and what success is a very important point. We will absolutely get to that, but let me actually give you the conclusion right here at the outset. By going to the second slide, where we actually have listed the 5 essential strategies that Douglas outlined in the insideHPC white paper. And we're going to go through each of these in a little bit more detail. But basically, as you can see here, there is the need to manage the impact of software complexity, the need to plan for growth, and in some cases, especially as is typical these days, extremely scalable growth. The third point has to do with the reality of hybrid architectures today and the challenge that brings in. So I'm thinking of things like accelerators, like GPUs and coprocessors and so on. A little bit more on that shortly. And then, of course, what really I think helps to really ground this particular white paper in today's reality, but also give a little bit of a view to the future, is the fact that Douglas has also talked about the importance of being able to incorporate the cloud in some fashion and having an answer for the question around Hadoop when people come to you about that. So we'll touch on those points as well. And so on the next slide, I've tried to summarize my take on what Douglas describes as what success actually looks like. So the real success factors. There's no point talking about 5 strategies and for success unless you actually define something about what success looks like. So the first point has to do with the importance of being able to make a cluster work productively for your organization. And a very typical metric that organizations look at is, of course, the level of utilization. And so there may be a number of different ways that people might want to quantify this, but this basically comes down to the productivity angle. How productively is your cluster being utilized? And that, of course, has both technical and non-human elements to it, if you like, but also there's a very substantial human side to it as well. The second point that I extracted from Douglas's white paper, I think, is one of my real soapbox kinds of items. The fact that change is inherent. Change is inevitable, whether it's because of emerging requirements within your organization, or as a recent great demonstration helps to amplify the occurrence of some vulnerability, such as the heartbleed bug. Change is absolutely inevitable. So these clusters, as we've kind of been hinting at in our initial our initial dialogue, Rich, they're complicated architecturally. They're complicated systems that are with a lot of integrated parts. Not exactly necessarily moving parts, but certainly a lot of integrated pieces that need to be brought together so that they can be utilized as a single resource. So it's important to be able to monitor these systems that can be made up of disparate parts, different instances of Linux, for example, different hardware components, different software components in the stack, and so on. And then you've got to be able to maintain all of this. And this is, again, one of the real challenges. It kind of in some ways reemphasizes the inevitability of change in this context, but it's also worthy of itself in drawing it out in an operational context. And then I guess the final point that I kind of translated for our audience today is that it's important to manage the operational expenditures in a clustered environment. There are significant costs, let's face it. And I think one of the points that Douglas makes extremely well in the paper is that even though you can go out and cobble together some sort of a cluster solution based on various components and toolkits and so on, there really is a real cost to that. And as I say, I think I would encourage our listeners to of course, read the paper because I think Douglas does a very credible job of trying to put that into context. So, the seeming notion of free is certainly not free from an operational perspective. So let's go ahead and move on to the next slide. And what one of the other points that I think the paper I think is a very nicely self-contained piece of writing. And one of the other topics that Douglas gives consideration is the notion of the different building blocks that you need to muster together to actually put together an HPC cluster. So in the slide that I've called here architecture, you can see what is a kind of a typical Beowulf style cluster. And of course, we're happy to use that name at this particular juncture in time, Rich, because there's a huge anniversary coming up for the whole notion of Beowulf clustering. And so this is a very typical deployment topology. You have the notion of a head node, and I'm actually circling it, even though I know that our viewers and listeners can't see that. But you have right in the middle of the slide here the notion of a head node, and of course, this is really the point of the major point of control for from a cluster management perspective. And then you have a number of compute nodes, which I've shown on the right part of this slide. And there's an agent that runs on each of these nodes that collects metrics and sends those metrics back to the head node. We summarize that information and so on and so forth in the context of monitoring. And this agent-based technology is typically also where the notion of the management component gets actually distributed out to the different nodes. In the case of our own solution from Bright Computing, Bright Cluster Manager, you can see that we call this our cluster management daemon, or CMD, CM daemon variously. Now, of course, you have to be able to interact with this system, both from the administrative perspective as well as from the user perspective. And there are a variety of ways in which that can actually be facilitated. One of the ways that we'll be showcasing later on in the case of Bright Cluster Manager is the graphical user interface that we have available. And you can see that in this slide on the left-hand side, that is one of the entry points, if you like, for the cluster from an administrative perspective. Now, we fully recognize that a lot of people have a real commitment to making use of command line interfaces. So, in fact, in the case of our own product, again, we have a command line interface that is really extremely closely feature functionality equivalent to what's available from the graphical user interface. Users can access a Bright Cluster Manager managed environment through a web portal or through a number of different third-party applications. So that's kind of a quick overview, architecturally speaking. And if we go to the next slide, you can see that there are a lot of pieces that are involved in building a high performance computing cluster, and there's far too much detail for us to go into in this particular podcast. But basically, everything is built around this central blue layer here, which is supposed to symbolize the Linux operating environment, whichever distribution happens to be of interest, and that Linux environment allows us to make use of everything from power distribution units to the out-of-band control capabilities that allow you to do things like power cycle servers remotely and get remote consoles and collect environmental information. The management compute fabrics that are delivered through everything from Ethernet to InfiniBand and so on and so forth. And of course, the traditional physical components such as disks and RAM and CPUs and whatever your chosen add-on might be, whether it be an accelerator, typically GPUs, or a something like an Intel Xeon Phi coprocessor. On top of all of these, if you like, bare metal resources and the Linux operating environment, there are a number of other components which include various management capabilities. So you can see there's obviously a provisioning capability, there's a workload management capability, monitoring, health checking capabilities, and then a whole slew of tools and libraries and APIs and so on and so forth that facilitate the complete layer, the complete top to bottom layer of a stack, right from bare metal right up to the end user, the scientist, the engineer. Wrapping all of this, as I was mentioning before, is our cluster management daemon, and then in red you can see that there's a security layer, and then beyond that there's of course the various entry points that I was mentioning before. I apologize for going through this so quickly, but these are some of the building blocks, and Douglas absolutely does touch upon all of this in the white paper, and obviously there's a lot more to the story, but we'll save that for another time. So we'll go ahead and move on to the next slide, which fortunately is just a replay of the 5 essentials slide. And what I want to do now is just take a couple of minutes, Rich, to focus in on each of the points that are drawn out by Douglas in the white paper. So the first one has to do with the impact of software complexity. And again, what I'm going to choose to do is illustrate this through our own Bright Cluster Manager. And so what I really want to highlight here is when Douglas talks about the challenge of managing the impact of software complexity. I think one of the things he really does a nice job of drawing out in the white paper is the need to take some time ahead of time to think about what sort of skills your organization has in terms of its administrative support personnel already. What sort of time is available for the project or projects for which HPC clusters are required, and what sort of costs are going to be involved for you, and of course the choices you make around choosing different options have a huge impact upon those costs. So this is one of the images, one of the illustrations. It's clearly it's a screenshot from Bright Cluster Manager, and this is one of the ones that we put into the white paper to help Douglas make some of his points. And what you can see here, this is just a static screenshot, but basically, hopefully, what you get a sense of is along the panel at the left, the various resources that Bright Cluster Manager is capable of managing. And you can see that it's that full sort of compilation of bare metal components from the power units, the networking components, networking switches, right on through to the accelerators and CPUs and coprocessors and so on. So everything is a resource really, and there are some other specialized resources that we'll talk about as we work our way through some of the other points in the white paper. But really, one of the points I wanted to make here in terms of managing complexity is, and why I chose this particular image to share with Douglas for the white paper, is I think it does a really nice job of illustrating that you may have collections of compute nodes, logical groupings, if you like, for which you'd like to be managing a particular software image. So Bright Cluster Manager allows you to do that. But what's really interesting is that in our latest release of the product, which was announced earlier this year, and we did pre-release demonstrations last year at Supercomputing in Denver, is that you can actually implement revision control for entire software images. So in the same way that you can manage revisions for source code or configuration files using the popular set of tools, whatever your particular choices from Subversion to Mercurial, what have you, you can do the same kind of thing now with software images using Bright Cluster Manager. So what we're showing on this particular image here is that for this image called the default image, the aptly named default image, you can see that we can actually check in for the purpose of registering within this context of revision control a known revision of the software image. And then we can go ahead and make changes to it and check in those changes as appropriate. And of course, the other great advantage of having revision control applied to entire software images is that you can actually revert to a previous version of that software image. So I've actually been in situations, Rich, where I've been responsible for managing software images for academic units at a local university, and we try to do things well ahead of term, and everything gets put together. We get the so-called gold image put together, and then somebody comes along at the last minute, or probably even more likely within the first week of classes, and says, hey, we'd like to make some changes. We'd like to add in this latest release of this software, or there's an important fix we need to address, or perhaps it's a security fix. With a capability like this, you can make extremely granular changes and really mitigate risk, because if you are having difficulty getting the new revision put together, you can always revert. So it's a great feature, and now it's not only just for your source code and your configuration files, it's for entire software images. So as you can see here, we've actually got we've actually got multiple images here that are being managed. Okay, well, I've probably said too much about that. Let's go ahead and move on to the second point of the 5 essentials, which has to do with planning for scalable growth. And I'll also go ahead and move on to the slide where I talk about this Cisco UCS system as a good illustration within this particular context. So, I've now worked for about 4 different software companies, Rich, and all of them in HPC, and all of them with an interest in delivering scalable solutions. And if there's one thing I've learned, is that scalability is not something that gets factored or refactored into your product by accident. It's something that takes a tremendous amount of effort. And This is, I think, one of the really important areas. If you look at the white paper that Douglas put together, you'll see that he talks about um, the right context for perhaps exploring the different options. So if what you want to do is just start to learn about HPC clustering, maybe it makes sense to start trying to build some things yourself, or maybe it makes sense to test out a toolkit. But if you want to start getting into really scalable situations, you really do need to go to something that has already got scalability baked into its real into its DNA. The other point that I think is that Douglas really draws out nicely in the white paper is the importance of testing. So if you go with something like a toolkit oriented solution, or you put together your own solution, chances are you may not even find out its scalability parameters until it's far too late. Things are breaking when you need them to actually be working, and that's when you discover what your scalability limits are. That's a very common experience, and I've actually experienced that in different ways at all four software companies. So again, scalability is something that really does not just happen. So we have customers that actually have got literally thousands. Now we're getting up to more like tens of thousands of nodes in individual clusters. With the Bright Cluster Manager cluster management GUI, you can actually introduce multiple clusters within the same instance of that GUI. You can have cloud-based resources, as we'll see in a moment. You can have different kinds of resources. You can make everything look to the administrator as if they're looking through a single pane of glass into their infrastructure, even though the resources may be physically located quite seriously around the planet. I mean, that's extremely common. So what we're trying to show in this particular slide here, again, another screenshot from Bright Cluster Manager, is a number of nodes, and one of these nodes actually being a Cisco UCS C-Series rack server node, which is these are extremely interesting nodes. We've recently added support for these particular nodes, and they're extremely flexible kinds of systems that you can introduce into your cluster, and be able to manage them right down at the BIOS level. So that's one of the other capabilities that I just wanted to highlight. The other point around scalability that I also wanted to mention, if you I hope you won't mind me jumping back just a little bit, but if you jump back to the slide that I had on the basic architecture, the architectural slide, one of the really fine advantages that we were able to really reap the dividends on is having this unified approach to introducing a cluster management solution. So the fact that we have a single agent for everything that I'm talking about. So in the case of Bright Cluster Manager, there's a single instance of this cluster management daemon that runs on all of the compute nodes that are part of your cluster. The fact that there's just one, it's a lightweight process. There's no redundancy that's introduced here, and as a consequence, this is another place where we're able to really help push the bounds on the scalability piece. Okay, so if you'll forgive me, I'm going to ask you to jump back now to the third point of the 5 essential strategies. And so what I want to do now is focus on the notion of planning to manage for heterogeneous hardware software solutions. And let's go ahead and I'll show you another screenshot here from Bright Cluster Manager. And this time I'm going to put a little bit of emphasis on general purpose graphics processing units, so GPGPUs. So I think that at this point, you can call upon all kinds of reference points, and I know Rich, you make the rounds at all the different industry events and talk to a lot of vendors and customers and so on and so forth. And I'm sure you'd be somebody I wouldn't have a hard time convincing that heterogeneity is basically the I don't even think it's fair to call it the new norm, but it is absolutely the norm today. So HPC clusters are actually hybrid architecture systems. And whether it's coprocessors or, in fact, accelerators, as we're illustrating from this particular slide here, there's a need to provision, monitor, and manage all of this. And this is, of course, again, another point that's really drawn out well by Douglas's white paper. But perhaps an even more profound point that I think he draws out is the importance of being able to manage your different classes of architectures, those with GPUs, those with CPUs, those with coprocessors, using a single management solution. If you have to use multiple management solutions to take care of a hybrid architecture cluster, I think you're to put it bluntly, you're really in for a world of hurt. That is just not a scalable situation. So, and we've absolutely seen this as a requirement stated rather explicitly from customers. A requirement, a must-have, a mandatory requirement on their RFPs. So again, the importance of having a single management solution is absolutely key. And what I'm showing you here on this slide, Rich, that we also provided to Douglas for the white paper, is being able to actually set the clock speed on a GPU, a recent generation GPU, a Kepler class GPU. This is something that NVIDIA calls their GPU boost technology. So without having to know all of the intricacies of how to work with GPUs and the different interfaces that NVIDIA makes available to you, you can just go down and do this directly from within Bright. Let's move along to the fourth point, being ready for the cloud. Obviously a very topical thing, continues to be topical these days. And I apologize, this screenshot looks like it's just a little bit of an eye chart. Again, in this particular case, I think Douglas has made a number of really important points in the white paper. It makes sense to get involved with a cloud offering that has, well, knowledge of what HPC customers actually require. So it's an HPC-centric offering. Not all of them are. A lot of them are extremely generic. There are a number of very good ones out there. The other point, another point that he makes in the white paper that I wanted to emphasize is the importance of being able to extend what you have within the organization, on the ground, as we like to say, in your data center and so on, and being able to very naturally and easily, pretty much transparently, extend that into the cloud. You still have needs to be able to provision, monitor, and manage in the cloud. You need to be able to know what's going on from a usage perspective. Bright Cluster Manager has a number of interesting capabilities in this particular area, including the ability to, for example, schedule workload to start taking place only when data is actually successfully being transferred. Bright can also allow you to, for example, maintain persistent resources in the cloud. So you could keep software images on a specified node in the cloud, or in fact, you could keep data sets on a node in the cloud. And what this particular screenshot is trying to highlight for our audience, Rich, is the fact that Bright works in concert with workload managers. In this case, it's Altair PBS Professional. And in fact, this is a great dynamic use case, which that particular aspect is not conveyed in our static image here. But the idea is that, in fact, Bright Cluster Manager works in concert with Altair PBS Professional to spin up resources in the cloud in response to queued workloads to ensure that those workloads are in fact processed effectively, and then the whole cloud environment is deconstructed after everything is complete. This is we do this extremely effectively with Amazon Web Services today. This is actually a capability that's been around for at this point over 3 years, so it's quite mature. And we're still adding to this capability as well. For example, we've just made an announcement regarding the availability to manage OpenStack-related private clouds, in addition to this extension into the cloud. So workload management integration, again, extremely important in this and really every other context. And finally, we'll move along to the fifth point, Rich, which is shown on the next slide, which is being able to have an answer for the Hadoop question. And I think and I've got a couple of screenshots to share with you to try and make this a little bit more compelling, an illustration, if you like, of this fifth point from Douglas's white paper. I think one of the great points that we really liked about the white paper was that Douglas said that you should expect the Hadoop question, and you should be able to respond to it. So you should anticipate it and be already able to respond to it. And I think equally as important is, and if you'll forgive the almost pun-like flavor to this, he makes it very clear that Hadoop is very much a different animal, a different beast from the traditional HPC world. And so you shouldn't necessarily expect everything to be the same. I think he even makes the point that in some respects, Hadoop has potentially more moving parts. There are certainly a number of different services that need to be managed in the context of Hadoop environment. You need to be able to, of course, provision, monitor, and manage in this case as well. One of the great distinguishing capabilities for our own Bright Cluster Manager in this perspective, Rich, is the ability to start off with quite literally bare metal and to stand up a complete managed cluster and then have Hadoop functionality present. So in this particular screenshot, there are two of them, as I said, that try to illustrate the Hadoop functionality within Bright Cluster Manager, within the white paper that we supplied to Douglas for the purpose of illustration. What you can see here is that we have an instance of Apache Hadoop that's already been stood up. It's got the very clever and distinguishing name of HDFS1. You can, of course, choose to put in a slightly more meaningful name should you wish. And you can see that on the left-hand part under the resources, in the resources panel, you can actually see that Hadoop HDFS actually appears as another resource, completely alongside your various HPC capabilities. And those HPC capabilities may include the ability to extend into the AWS cloud, for example. And as of roughly sort of the end of this month timeframe, your capabilities could also include the ability to manage an OpenStack private cloud in addition to Hadoop. So you really do get everything presented to you through this nice, simple graphical user interface. Now, the great thing for us is even though the add-on to support Apache Hadoop is relatively new, really all we're doing is adding on the capability to take our notions of monitoring and management and provisioning into this new area. So we're extending our footprint, if you like, into the big data space, into the high performance data analytics space, and so on and so forth. And so this really isn't something that will come across as a brand new product. It'll actually come across as something quite mature. And in fact, the next slide is a great illustration of that, because what we're showing on the next slide are some very, very tailored Hadoop-specific metrics. And we've got raised here a particular tab that's looking at data nodes within Hadoop. And you can see that we're showing everything from various block-related information, IO-related information, and along with various kinds of timing-related statistics. These are all time series, Rich. So you can see time running along the horizontal axis, and then the color-coded plots for what is actually being plotted on the vertical axis. And I suppose another thing that I just want to illustrate here, well, I guess we have already illustrated, there are a number of different styles in which these plots can be rendered. So obviously a number of DFS-related metrics, summarized metrics for Hadoop, because the JVM is Java virtual machines are a central part of the Hadoop capability. We have a number of metrics that are very specific to the JVM side of the equation, if you like. And again, everything we've learned in terms of workload management from an HPC perspective now has been refocused in the Hadoop context at the Yarn workload manager. Very different kind of capability in terms of workload management than what we're accustomed to from HPC. But again, we're able to take a lot of what we've been able to already provide in the HPC world, and now very rapidly make it available in the Hadoop context. So with that, I'm finally back to again the 5 essential strategies, which seem to me, Rich, to serve as a great summary of the presentation that I've given as well, and the importance of being able to come up with to the importance of being able to make use of solutions. And that word solutions is an important one here. Solutions that allow you to manage the impact of complexity, particularly from the software perspective, to embrace the need for scalability and change, to handle heterogeneity and the various ways that it creeps into HPC and other contexts here, to be able to extend into the cloud and to be able to deliver solutions not only for high performance computing but also for big data. And as those two worlds become increasingly converged, I think you agree that a capability like this just increases in value. So with that, I think I should definitely stop talking about the presentation.
Well, great. Well, hey, Ian, thanks for that. I think you've done a great job as, kind of laying out what Douglas presented in his paper. A way to pick the right road and kind of minimize your pain with a new cluster. But I wanted to ask you about, in your experience, what if I've got a bunch of clusters and they were written with, managed with scripts and everything? Does Bright offer me, some value there and a way to move to a more logical process?
I think it does. I want to be completely frank with you.
Yeah.
The transition, it's the kind of thing that we do see customers doing. I think what you can do is gradually shift the management solution into the Bright domain.
Mm-hmm.
We see people doing that in a variety of systematic ways. To be completely honest with you, what we've seen a lot of happening in the real world with real customers is this is where, together with our partners, and perhaps that partner might actually be the customer itself, we kind of take more of a professional services approach to helping to aid that transition. The reality, Rich, is, as I'm sure you're aware, that the complexity here, the breadth and depth of all the touch points it can be quite involved.
Sure.
And so these migrations are something that do take, frankly, some planning and are probably best achieved with statements of work and professional services and so on.
Yeah, yeah. And Ian, in the context of how the HPC world is changing, I've been reading a lot of articles about how big data and Hadoop is kind of
Hmm.
changing people's approaches, and vice versa. Are you seeing that out there?
Oh, absolutely.
Yeah.
I think probably one of the ways in which I wanted to try and highlight that a little bit was, by talking about the convergence of
Yes.
HPC and Hadoop. Rich, we both go to shows like Supercomputing and ISC and all these other ones, and there's a lot of influx of interest in big data in those particular contexts. We see everything from um, you know potentially customers and certainly some of our partners viewing everything as an HPC problem to probably almost the exact opposite. I suppose it depends upon what your entry point was, but I think it's pretty clear that somewhere there are various points of intersection. And so, in many ways, we feel like we're fairly uniquely positioned with Bright Cluster Manager to be able to offer a solution that really allows you to straddle these two sort of domains and get to choose yourself where you want to draw the distinction
Hmm.
between the different worlds.
Well, yeah, I wanted to ask you a little more specifically because
Hmm.
I'm imagining this researcher that wants to do some Hadoop projects, right?
Yeah.
And uh, can he get into the Bright Manager at certain levels, or is that only for the system admin, the lord of the cluster, to do that for him?
Um, I, I mean, I suppose it depends what you mean. If our API, for example, is we've actually just issued a brand new a set of documentation which documents the Bright API,
Hmm.
which means that anybody at the site, whether it's admins or end users, could actually start writing code and making use of the Bright API.
Yeah.
The API, as you're probably anticipating, and partly where your question's coming from, it doesn't just apply to our HPC offerings. It also applies to everything from the Hadoop perspective as well. So yes, you absolutely could. I do want to emphasize too that with Bright Cluster Manager and the Hadoop add-on, the customer still gets to choose, and this is a point I really should have made before, Rich, so I appreciate the opportunity. The customer gets to choose which distribution of Apache Hadoop they make use of. So if they
Hmm.
want to use the vanilla Apache Hadoop, no problem. If they want to use Cloudera, CDH, or if they want to make use of Hortonworks, they can go ahead and use whichever distribution they like, and basically just have Bright take care of managing that for them. So I think again, and to get back to the white paper for just a second, as Douglas mentioned, if you need to stand up a Hadoop environment in a hurry for a project, or if you want to just actually start getting to the point of making use of Hadoop, Bright Cluster Manager can really, really reduce your learning curve, your time to actually being able to get to use this.
Yeah, I mean, Hadoop has such a reputation for being just a bear to set up, and it's not for mere mortals, right?
Right. And, and
So,
and frankly, Rich, that's one of the reasons we're there.
yeah.
Is that, and we're doing the same thing for OpenStack. Is we people do absolutely realize the value in this, but again, as I think Douglas makes very clear from the white paper, that we've moved away from this trend of the need to have heroic efforts from a sysadmin's perspective to get just to stand up an environment to saying, no, we want to do something useful. We
Hmm.
want to spend our time on something worthwhile, and so you're absolutely right. Part of it is what we're trying to do is accelerate the ability for people to start being able to use these things.
I guess that's really what it's all about. So,
Yeah.
yeah. Well, Ian, hey, I want to really thank you for coming on the show today and putting this all in perspective for us.
Thank you very much, Rich. It's been a pleasure.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high performance computing.